Hi and welcome back. So in the last video we were kind of talking, or we started talking about how an electron configuration would look for a hydrogen or a helium atom. That we would say that a configuration for hydrogen would be 1s1. 1 is the period that hydrogen is in, s is the type of orbital we have, and then we've got one electron. And then helium would look exactly the same, just that we would add a second electron onto that hydrogen atom. Let's actually start talking about another element. Let's start talking about lithium. So this is element, its atomic number is 3. I don't know if you're supposed to say it's element number 3, but anyway, lithium's atomic number is 3. So that means, and we're all of these electron configurations we're doing, at least for the beginning, they're all going to be neutral atoms, so they're going to have the same number of protons as electrons. So what do you think would lithium's electron configuration look like? And the first thing, I guess, to realize, and let's actually go down and look at our chart. So essentially, what we're going to have is we are still operating, I guess, within the realm of this s orbital. We haven't started to venture out into these other strange looking orbitals yet. We're still sort of in this realm of the s orbital. But now, what's the big difference? Well, the big difference is that our period, we're down on the second period now that we're looking at lithium. And essentially, what this is going to, or what you could say that this would look like if we were going to look at an atom of lithium, where if we go back to our example where we had either hydrogen or helium, and actually I'm going to erase the labels so we can maybe write in that we're looking at lithium. But essentially, what we're going to have is we're going to have another s orbital. So we're going to have another sphere-shaped orbital. But actually, it's not going to be so much a sphere. It's going to be a shell. Actually, it's going to be I'll actually maybe do a dotted line like that. It's actually going to be a shell, or it's going to be, you could say, like a hollow sphere. And essentially, what we're going to have is we're going to have our two electrons that are in our 1s orbital. So this is the same orbital that we were looking at for either a hydrogen or a helium atom. And we've got two electrons inside this cloud. But then what we're going to have is we're going to have another shell, or another sphere on top of that sphere. And that's not the greatest. It's supposed to be a sphere of some type. I didn't do the greatest drawing. Maybe I'll scroll up, and that's not much better, but anyway. So this is, what we're going to have is we're going to have sort of another sphere on top of that first sphere. And what this is going to be called the 2s. And essentially, it's going to look very similar, where we're going to have a high probability towards, I guess you could say, the edge, towards the closer we get to the nucleus of our lithium atom, we're going to have a high probability around the edge of the atom. We could shade it in like that. And then as we get out, as we move farther away, we're going to have a lower probability. So if we had our same depiction, we would be getting into, I guess, our more white zone, where we're going to have a much lower probability of finding our electron. And so you can also imagine our 1s orbital, how many electrons are going to be in this. This is our 1s orbital. Well, it's going to be full, right? Because we're adding electrons. So we started out, we're going to have to fit in two electrons, because we're going to have one electron would look like hydrogen, 2 electrons would look like helium, and then 3 would look like lithium. So essentially, we're going to fill up our lowest, and we could say that this is our lowest energy orbital, and maybe I'll do the next video. I'll maybe talk a little bit more about how electrons have more energy as we move out from the nucleus. But we're going to fill up this orbital first, this 1s orbital, because it's essentially the lowest energy orbital. So this orbital is going to have 2 electrons in it. And then our lithium atom has 3 electrons total. So how many electrons are going to go into our 2s orbital? Well, there's only going to be 1, right? So our lithium electron configuration, if we were going to do the same exact configuration, we would start out writing our 1s orbital. So our first orbital is 1s2. And then our next orbital, we're taking the period, and you can do this for if you were doing the orbitals in, I guess, reverse order. If you were starting at the end of the electrons, you could start by just saying, well, what period is the element in? Lithium is in the second period, so we're going to start off with we're going to be in the second period. It's an S type of orbital, and there's 1 electron inside of that orbital. So this is going to be our configuration for lithium. We have 1s2 and then 2s1. So we've got 2 electrons in this 1s orbital, so that's really close to the nucleus. And we've got, you can imagine that we still have this nucleus has got, let me choose a better color. This nucleus still has a positive charge, right? And these electrons that are floating in have all got negative charges. So essentially, the attractive force, these negative charges want to get as close as they can to this nucleus, but these negative charges at the same time, they're being repelled by each other. Right? They don't, negative charges, if you took the negative ends of a magnet and tried to push them together, they would sort of force themselves apart from each other. So and pretty much the same thing is happening on the atomic scale with electrons, that these electrons are attracted to the nucleus. That's why the concentration of finding an electron, or the probability of finding an electron, is greater around the nucleus than it is at the edge of the atom, because of this attraction. But part of the reason that we can only fit 2 electrons into each orbital is because of this repulsion. It's because of the fact that electrons are repelled by each other. Electrons don't like to be around each other. You could say electrons really need to, I guess, have their own space, which is why, after our 1s orbital is filled up with 2 electrons, the next electron needs its own orbital. It needs to be in this outside shell. So, and again, there is a certain amount of probability that an electron could actually make it into this 1s orbital. It's a very low probability, and we don't necessarily need to talk about that right now. We'll probably talk about that more towards the end of this playlist. But, essentially, and you should always remember, the thing about these orbitals is that they are probability functions, that they are the likelihood of being able to find an electron in a certain area. And, essentially what is keeping the electrons around the nucleus is this positive charge in the nucleus. And essentially what makes these electrons need their own orbitals is the fact that, if we have 1 electron here, it's going to be repelled. There's a repulsive force between all of these electrons. These electrons want to get essentially as far away from each other as they can. And anyway, I think that's enough. Actually, you know what? Let's do, before we end this, let's just do, this element is atomic number 4. This is beryllium. Let's just do, I think we're well equipped enough to do the electron configuration for beryllium. And actually, why don't you, if you want to try to do it yourself before I let you know the answer. Maybe if you want to pause the video and do it real quick, that might be a good exercise. But anyway, I'll do it right now. So So we're going to start out with our 1s orbital that I've drawn over too much. And we're going to start out and we're going to fill up that orbital completely with electrons. So we're going to say 1s2, that orbital is now completely filled. And so now we're going into the 2s orbital. And how many electrons? We know that beryllium, if we're looking at the neutral atom, beryllium, what defines beryllium as an atom is the fact that it has 4 protons. And we know that we're looking at the neutral atom, so we know we need 4 electrons. So we're going to have 2 electrons in our 2s2. So we've got 2 electrons here, 2 electrons here. That means that we've got 4 electrons around our beryllium atom. So anyway, in the next video, we're going to start talking a bit more about other types of orbitals. We've been talking all about the s orbital. So in the next video, we're going to start talking about the p orbital, and maybe we'll get into the d orbital as well. So anyway, thanks so much for watching, and I'll see you in the next video.